Hi, this is my assignment on transmittance effects for the subject real-time rendering. Here we have a cube map, an environment map of Lancelotti Chapel in Italy. It gives an illusion of 360-degree space, but these are just a bunch of pictures mapped on a cube. So this is our cube map here. Here the first teapot is reflective, so it reflects the light striking on its surface. So the second teapot is refractive, so it refracts the light striking on the surface. So I've given refractive index of water here. The third teapot is a combination of reflection and refraction, and the fourth one is the Fresnel effect. So in the left hand side I haven't considered the view angle and the Fresnel factor. So in the Fresnel effect we get a more realistic results. The last one is the chromatic dispersion. So here we can see whenever light strikes on the surface, it gets dispersed. So light, so the red, blue, green, all the colors disperse at different times. So we can see different colors here at the end. Also, I've given the teapots here a slight blue color, a tinted, so to give them a tinted blue color feel. So this was my output. Now let's look at the shader codes here. So most of the thing are done in the shaders here. So this is my vertex shader. Here we get the vertices and normals as the input, and here we calculate the normal and position in the world frame. We give them as output for our fragment shaders. In the reflection, I've used this reflect function with the view vector here. I use the view vector and normalize normal, and I've given this as my output. And this vector 4 here describes the blue color, a slight blue color I've given to the teapot. In the refraction, instead of reflection, I've used the refract function here, and in the Fresnel, I've calculated the refraction, and also this factor, Fresnel factor here, which I've given these constant values here. And the final R is calculated by mixing the refraction and the reflective factor, or the Fresnel factor, whatever we call here, and then we get our final output. The chromatic dispersion, it has a slightly different factor. So we first calculate the our reflective color. So after the reflected color is calculated through our reflect function, and then we take and for refraction we take vectors. We take the x, y, z components. So we have different refractive indexes for different colors, for different wavelength of for different wavelengths. So for red I've used this x, I've used the x, for green y, and for blue z, and then I've calculated the RGB of the refracted color from the textures RGB respectively, using the refracted vectors we calculated earlier. We then mix the refracted color, the reflected color, and the factor together, and here I've multiplied again the tinted color to give a tinted feel from the blue color, and this is the final output we get. So this was it. Thank you.